Demonstration problem 1. A ball is thrown straight up with an initial velocity of 28 meters per second. We note that that's metric. Part A. How high does it go? Again, there are 5 things. S, the displacement, time, V initial, V final, and the acceleration becomes the acceleration of gravity, or G. The givens, we need 3 things. The initial velocity is 28 meters per second. Velocity is a vector. Its magnitude is 28 meters per second. It was thrown upwards, which is the positive y direction. V final at the top of the ball's travel is 0, and the acceleration of gravity is 9.80 meters per second in magnitude. It is in fact in the downward direction. There is a minus sign there, and the equation will incorporate that minus sign. The unknown, that's fourth, is what? How high the ball goes, that is the displacement. Remember, displacement is change in position, or y final minus y initial. We set y initial to be 0. Magnitude of the displacement is y final, or how high the ball went. What is the equation? Fifth is what? We have the 3 things that we were given. We check those off. The fourth is what? That's what is the displacement. The fifth not known is the equation that will work. That's time not known. We write that equation down. The final velocity squared is the initial velocity squared minus twice the acceleration of gravity times the displacement. We complete the guess method by adding in substitute and solve. We use the givens to populate the equation in the substitution phase. We get 0 squared is 28 meters per second quantity squared minus twice 9.80 meters per second squared times the unknown s, or the displacement. Evaluating to 3 significant figures, we get a displacement of 40.0 meters. Part B. How long did it take for the ball to reach its maximum height? We have the same 3 givens as before, and we check those off. Fourth is what, or what is the unknown? We need the time to the top. We put a question mark underneath the time. The equation is fifth not known, or displacement not known. We write that equation. Final velocity is the initial velocity minus the acceleration of gravity times the time. We substitute in 0 is 28 meters per second minus 9.80 meters per second times the unknown, time to the top. We solve, and we get 2.857, round that to 3 significant figures, or 2.86 seconds. Part C, how long is the ball in free fall? There are 2 ways to do this. We'll look at both ways, and then you take your pick. The first way, need 3, or the given. As before, the initial velocity is 28 meters per second. We don't know the final velocity because that's the velocity with which the ball hits. What we do know is that the displacement is 0 because you threw the ball, when it left your hand, goes up to the top, it comes back down, and you catch it at the same height. Remember that displacement is change in position. The displacement is 0. The acceleration of gravity is still 9.80 meters per second. Fourth is what, or the unknown is what? We want to know how long the ball is in free fall. So what is the time? We check off the 3 things that we know. We put a question mark underneath the unknown, the time. The fifth not known is the final velocity not known equation. We write that down. The displacement is the initial velocity times the time minus 1/2 the acceleration of gravity times the time squared. Note that this is a quadratic equation. Substitute. 0 is 28 meters per second times the time minus 1/2 times 9.80 meters per second times the time squared. Simplify, that becomes 0 is 28 meters per second times the time minus 4.90 meters per second squared times time squared. Solve. This is a quadratic equation that's set to 0. It lacks the constant term. The solution method here is to factor out the unknown t. You get t times quantity 28 meters per second minus 4.90 meters per second times the time is 0. Here we have 2 factors whose product is 0. The multiplication rule of 0 says that when 2 things have a product of 0, one or both of them is 0. The time is 0. That's not the solution we want. Or 28 meters per second minus 4.90 meters per second times the time is 0. That's the solution we want. We solve and we get that the time is 5.71 seconds. The second way to do part C, for how long the ball was in free fall. The time that it leaves your hand to the top is the same as the time from the top till it comes back and hits your hand at the same height. This is because the force on the ball is the weight force on the way up and on the way down. From part B, we had that the time to the top was 2.857 seconds. Therefore, the time that it hits at the same height is twice the time to the top, or 2 times 2.857 seconds, or 5.71 seconds as before.